of logs, we already kind of know, even though we haven't like defined them yet. But the log of 1 is always equal to 0 because any base raised to the 0 power always gives you 1. So just like in exponent world, anything to the 0 power is 1. In log world, the log of 1 is always 0. So remember, logs are inverses. So if there's a property in exponent, so it's important to know the log of 1 is always 0. The second one, if the base matches the number inside, the answer will always be what? So if the base matches the number inside the log, what do we know the answer to this always will be? 1. Because base raised to the first power gives you back the base, right? I'm just changing it into exponential form to kind of prove it. All right, what would the next one be? If the base is getting raised to the y power, you get the base to the y power. So this will be equal to y, because remember our circle, the little base raised to the y power gives you back the base to the y power inside. So b to the y equals b to the y. The last one is a little bit hard to understand, but the base and the log base cancel, and you just get x. And the reason is because inverses undo each other. So it's kind of like taking the square of a square root. We're taking the base of a log to a base, so it cancels and you get x. I'm not going to prove this one to you right now, but we'll see it again. Can you turn your notification things off so they don't ring in my ear every second? Yes, I figured it out after about the third one. I'm like, why is this hurting my ears? Okay, so here is something new. So product and quotient and power properties of logs, so that we're going to use to simplify log expressions. Before I do this, can anyone tell me what this simplifies to? X to the 7 times x cubed. X to the 10. What did you just do to the exponent? Okay. What if I have x to the 6 over x squared? What does that simplify to? What did you just do? Okay, so if multiplication we use addition for, and division we use subtraction for, those go together in log world as well. So here you're multiplying inside the log, so you're allowed to add outside the log. So I can split this up into two separate logs with addition. So instead of saying r times s, I can say the log of r plus a separate log of s, because the base stays the same. So how could I split up this example? If I had 21 inside a log, I could really say that's the log of 3 plus the log of 7. So log base 6 of 3 plus the log base 6 of 7. You're splitting up multiplication using addition. The reason this used to be more important was because you would have log tables, and you might only have the log base 6 up to 10. So I can't do the log base 6 of 21 out of my log table, but if I can split 21 up into 3 times 7, I can look this up in my log table and this up in my log table. So they used to need properties just to do the math. We could just calculate today log base 6 of 21. So we don't really need it for evaluating, but we're going to need it for solving logs. Okay, so this one gets split up with subtraction. So r minus the log of s. And the base is just staying the same. Whatever the base is over here stays over here. So if it's division, you can subtract them. Just like over here. When it was division with exponents, we subtracted. So how would I rewrite this one? I'd say this is the log base 4 of 2 minus the log base 4 of 3. So addition and multiplication go together, subtraction and division go together. So this last one is going to be also important. It allows you to take a power and move it down front and make it a coefficient. So I would have C times the log base B of R. So it makes it so you can bring the power down in front as a coefficient. So in this example, I don't know what 36 squared is. So I can bring the 2 down front and say this is really 2 times the log base 6 of 36. You don't have to write this next part down, but you should know what the log base 6 of 36 is in your head. What is the log base 6 of 36? 2. So this problem becomes very easy. 2 times 2 would just be 4. But when I'm over here, I don't know what 36 squared is, so this is too hard for me to compute in my head. And then the last property that we don't really need as much anymore, but it's called the change of base formula for logs. If you have an unknown base, you can take a common log of the number x and divide by the common log of whatever your base is on your calculator. And we've kind of already done this on our calculator, but we can take the log of 9 and divide by the log of 6 on our calculator to get this. Allows us to compute it, because I think on these calculators, does it have a math log base key? Yeah, so on the older TIs, there was no log base. So if I was using this calculator, I would have to take the log of 9 and divide by the log of 6. So I could find the answer, 1.22, but I'd have to actually divide it out. So when we get back from lunch, we'll go over the answers, but you got 2 minutes till lunch. Take a look at the true false questions 1, 2, and 3 and see if based on the properties, those are true or false. So take like 1 more minute because you got like 2 minutes. What did you say about the second example? The second example is identical to the third one down under basic properties or using the power property, right? Because isn't b cubed equal to b cubed? So this should just be true. Or you could say, I moved the 3 down front, then I have log base b of b. Does that equal 3? Yes, it does, because that's equal to 1. 1 times 3 is 3. So either way, it's true. What'd you say for number 3? Would that be true or false? How can I rewrite x squared? X times x inside the log. So isn't this true? Because I'm splitting it up into 2 logs with addition. I could also do it another way. I could bring the 2 down front as a power. Now I have 2 of those things. So I have 1 of those things plus 1 of those things. So this one would also be true. And these properties are hard. Right now, they're properties just for the sake of doing properties, because you need properties to solve with logs. All right, number 4 through 7 on the next page. You're going to take a look at your options here and use properties to figure out how you could simplify. So just draw an arrow. Like if you think 4 is C, just draw an arrow from 4 to C. There's one correct answer for each 4 through 7. So use the properties from the front. Are you multiplying? Are you dividing? Are you using a power? Take a minute and match them up. Did you match? Yep, see, 4 times 3 should have been 12, right? So 4 should have been D, because I take the 4 times the 3 because it's split up with addition here, so I would multiply it. This would be subtraction, so I'm going to use division, right? 3/4. So these are the power property. So the 3 slides up here and becomes log of 4 cubed. So you have to know what 4 cubed is. 4 times 4 times 4 is 64. And then this one becomes the log of 3 to the 4th. So the 4 gets to slide up and become the power. So the coefficient is actually the power of inside the log. So this one was the 81. And we're gonna try to use them on the homework and try to use them tomorrow when we're solving logs. This is really just practicing the properties. You're trying to rewrite these logs using just A and B. So if I see the log of 5, that's just equal to B. But the log of 15, I'm only allowed to use the log of 3 and the log of 5. So 15 is the same as 3 times 5 inside the log. So then what would I do with multiplication? I would use addition, right? It would be the log of 3 plus the log of 5. if I split it up into two separate logs? Well, the log of 3 is just a, and the log of 5 is just b. So I can simplify the expression up here using a and b. It would be a plus b. Let's do one more together, and then you're going to try 11, 12, and 13. 9. How can I rewrite the 9? Do I want to use log of 3 or log of 5 or both? Yep, so this is the log of 3 times 3 is 9, right? All right, if this is multiplication, I split it up and use addition, right? The log of 3 plus the log of 3 is equivalent to that. So each of those log of 3's are represented by a in the expression. So you could either say a plus a, or you could just say 2 times a. So it's a little bit abstract, but you're just trying to practice that multiplication is addition, and down here you'll have some division. So see if you can do 11, 12, 13 the same way, really thinking about the power or product or quotient properties. If you want to slide down and keep doing like 14 and 15, you're breaking it up into more than one log. So actually, why don't you can try 11, 12, and 13 in a minute, but I just want to show you how to do 14 and how to do 22, and that way you can kind of use the rest of the time to complete this practice. And I'll walk around. Number 14, I want to split up. If it's multiplication inside the log, I'm going to use addition outside the log. So I'll have log base 4 of 5 plus log base 4 of x. So those are equivalent. This is one log, this is more than one log. Down here, I want to condense the logs. So if I'm using addition, I'm going to multiply the 4 times the 3. So this is the log base 7 of just 12. Usually we don't want to expand. Usually we just want to condense our logs. But for now, practice using, go all the way up through 27. If you want to use your calculator for 25, 26, 27, that's good. Round to 2 decimal places. And that'll probably be where we end. I don't know if we'll have time to do more than that today. So see if you can, if you have -2 apples, how many apples do you have? You have one rotten apple, so -1 apple, and another rotten apple, so another -1 apple. In number 18, it's a little bit tricky. Oh, I guess I skipped on to 18. If you have -2, you can bring the -2 down front and make it a coefficient. So you have -2 of something. That means you have -1 of something minus another 1 of something. So I can just write negative natural log of x minus natural log of x. This is an L. This is not the number 1. I have negative natural log of x minus another natural log of x. I'm just going to keep going in this row because that's the row I'm in, and then I'll go back to the row before, I guess. I have 12x cubed. I would not split up the x cubed. I would just keep it as you've got the log of 12 plus you also have the log of x cubed. I just split these two things apart using addition, but I kept the word log the same. So on 15, kind of the same thing. You take the log of 7 and you add the log of x. So that's called expanding a log into more than one log. On 16, you don't have two items inside. X squared is x times x. Now you have two items that you can split apart, right? Because x squared is x times x. So you would have the log base 8 of x plus the log base 8 of x. So the base stays the same and you just split those two things apart. On 17, you have a subtraction problem because you're doing division inside the log. So log base 2 of x minus log base 2 of 3 would be the answer. So see if you can do 20 and 21. We'll go over 20 and 21, and then we might have to finish the last couple problems on this page as a warm-up tomorrow. But see if you can do 20 and 21 for 30 seconds on your own, and then I'll put up the answer to 20 and 21. And then the ones that I still have blank on here, I'll know that I have to do tomorrow as part of our warm-up. Try 20 and 21 right now. 20 and 21. So properties and logs, finish away. You're trying to just put it into more than one log. So you need two things to split up. So in number 20, I'm just going to circle. I've got a 4 and I've got an x squared. Those are the two things I'm going to split up in number 20. So I'm just going to write, I've got the natural log of 4 and I'm going to subtract the natural log of x squared. So I just split it up into two separate natural logs. Oh, I guess you're leaving.